All right, when predicting weather, you want to keep a couple things in mind. So let's start with pressure system. So pressure systems can either be low or high. Low pressure systems have air rising, which would cause clouds to form. Just think of our cloud in a bottle experiment. When you release the bottle, that's when it became cloudy. When you squeeze the bottle or simulate high pressure, the clouds clear. So it makes sense low pressure would be associated with clouds, storminess, and rain, whereas high pressure systems would be clear skies. So low pressure air rises and condenses to form clouds, high pressure air sinks and warms, and you have clear skies. And their other names are cyclone for low pressure and anticyclone or anticyclone for high pressure. Now, with pressure, it moves from high pressure to low pressure. So if you have two pressure systems near each other, the pressure from the high pressure system will move towards the low pressure to try to equal out. Those lines around a high pressure system are known as isobars. They connect points of equal pressure. So just remember, isobars are like pressure, like a barometer measures pressure. The next thing to keep in mind would be fronts. You can have a cold front when cold air encounters warm air and pushes it up to cause rain. You can have a warm front where warm air rises over top of cold air and it settles in there and warms up the air, and then you usually have a little bit of rain for a few days there. And then stationary would be when the front stalls. So whatever the weather is, it stays that way for a while. Then occluded front would be when a cold front chases a warm front, and it usually causes a pretty high disturbance like you might see with a cumulonimbus cloud. We use something called a station model to show data for an area. So if you look at my station model, half of my circle is shaded in. That represents 50% cloud coverage. You also might notice this number, 114. That's the pressure. So my 11 is less than 19, so I add 10 to the front and a decimal point in the tens place. So it becomes a pressure of 1011.4 millibars. Temperature is found in the left corner, and that would be 73 degrees Fahrenheit, and dew point is to the bottom left corner at 67 degrees Fahrenheit. And then wind, our wind direction, the wind is blowing from the north, and we have two long lines and a short line at 25 miles per hour. So that's your station model. Now, let's take a second and check out a real weather map. So, and the real weather map. So here we are on my computer screen. So this is our weather for today, which is actually May 19th. So this is a system coming across the United States. So our westerly winds are going to bring our system all the way to the east. So in a few days, we would expect this occluded front. So notice the cold front advancing onto a warm front, and then you get that purple section that has both symbols. This low pressure system is going to have with it a lot of rising air. So you would expect as this cold front comes in, thunderstorms should be forming in this area. And they'll be heading our way later in the week. We have a stationary front below us here to the south. And that means that this clear sky area is going to stay that way for a while until one of the systems moves. And right now in Virginia, it's a high pressure system. And as you would expect with high pressure, the skies are clear and it's relatively stable air. We don't have a lot of air rising to form clouds. Now, you notice up here, we have a low pressure system. We have storms in this stationary front area. So these things are all associated. The storminess is always associated with low pressure. So wherever there's high, there's no rain clouds. Low pressure tends to create rising air and clouds. So you'll expect clouds to be forming in the Midwest here soon. Other things you might see, the little white lines that are kind of hard to see, those are your isobars. So each of those white lines, there's one going around this L. They all go around one of the low pressure systems or high pressure systems. And those are isobars. Now, if we take a second and look at isotherms, that's going to be a temperature map. So let me switch us over here. To the current temperature reading and see if we can't look at some of the different ways it can be displayed. Sorry, it takes a second to zoom it in here. So this is our temperature, and the colors represent different isotherms. So we'd have an isotherm for the orange border here, and then we'd have another isotherm for the yellow. But this shows you the temperature changes. And notice in the middle of the country where that cold front is advancing, it's 92 degrees in front of the cold front. That's the warm air. And then you have the cold front advancing on the occluded front behind it, bringing in cooler temperatures. So you would expect it should get cooler in the Midwest as well.